In the vast expanse of the Atlantic Ocean, where azure waters meet endless skies, lies a region that has captured human imagination like no other. Here, in this seemingly ordinary stretch of sea between Miami, Bermuda, and Puerto Rico, reality and mystery dance together in ways that challenge our understanding of the natural world. Ships have vanished without sending distress calls. Aircraft have disappeared from radar screens as if swallowed by invisible forces. Radio transmissions have cut to eerie silence, leaving behind only questions that echo through decades. Yet beneath the supernatural folklore lies a far more fascinating truth. A story of human courage, scientific discovery, and technological triumph over the unknown. Welcome to the Bermuda Triangle, where every wave holds secrets, every wind carries whispers of the past, and every fact reveals another layer of one of the world's most enduring mysteries. 1. The vanishing of Flight 19. The afternoon sun hung low over Fort Lauderdale on December 5, 1945, casting golden reflections across the runway as 5 massive TBM Avenger torpedo bombers prepared for takeoff. These weren't just any aircraft. They were the Navy's workhorses, each weighing over 10,000 pounds and packed with the most advanced navigation equipment of their era. Lieutenant Charles Carroll Taylor, an experienced instructor with over 2,500 flight hours, led 14 young men into what should have been a routine training exercise over the crystal-clear waters of the Atlantic. The mission was simple, a triangular navigation course that would take them east, then north, then southwest back to base. But as their engines roared to life and they lifted into the December sky, none of these brave airmen knew they were about to become the central figures in one of aviation's greatest mysteries. Flight 19 was about to vanish completely, launching the legend of the Bermuda Triangle into the world's consciousness and creating a puzzle that would captivate investigators for generations. 2. The last desperate radio call. Static crackled through the radio speakers at Fort Lauderdale Naval Air Station as controllers strained to hear the increasingly frantic transmissions from Flight 19. At precisely 3:45 p.m., Lieutenant Taylor's voice cut through the electrical interference with words that would haunt maritime history. "Both my compasses are out, and I'm trying to find Fort Lauderdale, Florida." The radio operator's blood ran cold as he processed the implications of this transmission. In 1945, pilots relied entirely on magnetic compasses and visual landmarks for navigation. There was no GPS, no satellite guidance, no electronic backup systems. For both compasses to fail simultaneously was not just unusual. It was virtually impossible according to every manual and training protocol. Taylor's voice carried the weight of growing desperation as he realized the terrifying truth. He was lost over the vast Atlantic Ocean with fuel running dangerously low and darkness approaching fast. His experienced crew, who had trusted their lives to his expertise, now found themselves in an impossible situation with no way home. 3. The massive search operation. When Flight 19 failed to return to base, the U.S. Navy launched what would become one of the largest search and rescue operations in military history. The scope of the effort was staggering. Over 5 intensive days, search teams scoured an incredible 300,000 square miles of ocean and coastline. More than 300 aircraft took to the skies, ranging from nimble fighter planes to massive PBM Mariner flying boats, each equipped with the most advanced search equipment available. Surface vessels joined the armada. Coast Guard cutters sliced through rolling waves. Navy destroyers swept the deeper waters, and civilian boats volunteered to help in the desperate search. Weather reconnaissance aircraft flew dangerous missions through storm systems, while submarines dove to probe the ocean's mysterious depths. Thousands of military personnel worked around the clock, coordinating the largest peacetime search effort ever mounted. The operation consumed enormous resources and represented the full might of American military technology, focused on a single, haunting question: where had Flight 19 vanished to? 4. No trace left behind. Despite the massive search effort that deployed hundreds of aircraft and dozens of ships across 300,000 square miles of ocean, Not a single piece of wreckage from Flight 19 was ever found. This complete absence of physical evidence baffled investigators and fueled decades of speculation about what could have happened to 5 large military aircraft. The TBM Avengers were substantial machines. Each bomber was 40 feet long with a 54-foot wingspan, constructed of aluminum and steel that should have floated or left debris fields when they hit the water. Search teams found other wreckage during their intensive 5-day operation. They discovered crashed civilian aircraft, boat debris, and various pieces of military equipment, but absolutely nothing from Flight 19. The ocean had apparently swallowed 14 men and 5 aircraft without leaving so much as a life jacket or fuel slick behind. This complete disappearance violated everything search and rescue experts understood about aviation accidents over water, where debris fields typically spread across miles and remain visible for days or even weeks. 5. The USS Cyclops, naval history's greatest loss. In the cold waters of March 1918, the USS Cyclops disappeared into maritime legend, taking with it 306 souls in what would become the largest non-combat loss of life in U.S. naval history. This massive cargo vessel, stretching 542 feet from bow to stern, was no ordinary ship. It was a vital link in America's World War I supply chain, designed to carry precious resources across the dangerous Atlantic. Captain George Worley commanded this floating fortress, knowing that German U-boats prowled these same waters, hunting Allied vessels with deadly efficiency. But the enemy submarines that claimed so many ships during the Great War had nothing to do with the Cyclops' fate. The vessel simply vanished without explanation, leaving behind one of the most enduring mysteries of the sea. No distress call was ever received, no wreckage ever found, no survivors ever rescued. The loss represented not just a naval tragedy, but the birth of a legend that would grow more mysterious with each passing year. 6. The silent cargo of doom. The USS Cyclops carried more than just crew members on its final voyage. It bore 10,800 tons of manganese, or a cargo so heavy and valuable that it would forever change how investigators viewed the ship's mysterious disappearance. Manganese was crucial for steel production during World War I, making every ton worth its weight in military necessity. The ship had loaded this dense, metallic cargo in Barbados, filling its holds with, or that shifted and settled with every ocean swell. Maritime experts would later theorize that this particular cargo might have held the key to understanding the Cyclops' fate. Manganese ore is incredibly heavy and has a tendency to shift during rough weather, potentially causing catastrophic stability problems. When a ship's cargo shifts suddenly, it can create a fatal list that makes recovery impossible. The weight distribution could have changed so rapidly that the crew had no time to send a distress signal before the vessel capsized and sank to the ocean floor. This cargo would become a central clue in unraveling the mystery decades later. 7. The last peaceful message. From the tropical port of Barbados, Captain George Worley sent what would become one of the most haunting final communications in maritime history. Weather fair, all well. These 4 simple words, transmitted as the USS Cyclops prepared to leave Barbadian waters, carried no hint of the disaster that would soon engulf the vessel. The message was routine, professional, and completely unremarkable, exactly the kind of standard communication that naval vessels sent thousands of times during their voyages. Weather conditions were indeed favorable, with calm seas and clear skies stretching toward the horizon. The crew was healthy, the engines were running smoothly, and the ship appeared to be in excellent condition for the journey ahead. But these words would take on an almost supernatural quality as they became the last anyone would ever hear from the 306 people aboard the Cyclops. The contrast between this peaceful final message and the complete silence that followed has puzzled investigators for over a century, making it one of the most chilling communications in naval history. 8. The sister ship's tragic fate. The mystery of the USS Cyclops deepened considerably when 2 of its sister ships, USS Proteus and USS Nereus, met identical fates in 1941, both disappearing while carrying similar heavy metallic or cargoes. These three vessels were built from the same design plans, constructed with identical specifications, and operated under similar naval protocols. The Proteus vanished in November 1941 while carrying bauxite, ore from the Caribbean, disappearing without a trace, just like its sister ship 23 years earlier. 1 month later, the Nereus suffered the same fate, also carrying bauxite ore and also vanishing completely without sending any distress signals. The loss of all three sister ships under nearly identical circumstances suggested a pattern that went far beyond mere coincidence. Naval investigators began to suspect that these vessels might have had a fundamental design flaw that made them vulnerable to catastrophic failure when carrying heavy, shifting cargoes. The identical nature of these disappearances pointed toward a structural or operational weakness rather than enemy action or supernatural forces. 9. Star Tiger's fatal flight. The British South American Airways flight Star Tiger lifted off from the Azores on January 30th, 1948, carrying 31 passengers and crew toward what should have been a routine landing in Bermuda. Captain Brian McMillan, an experienced pilot with thousands of flying hours, commanded the 4-engine Avro Tudor 4 aircraft through the night skies over the Atlantic. The flight had been proceeding normally, with regular radio communications and no indication of mechanical problems or adverse weather conditions. Star Tiger was equipped with the latest aviation technology available in the post-war era, including radio navigation equipment and experienced crew members who had flown similar routes dozens of times. But as the aircraft approached Bermuda in the early morning hours, something went terribly wrong. The plane's radio transmissions suddenly ceased, and the aircraft vanished from all contact with ground controllers. Despite extensive search efforts covering thousands of square miles of ocean, no trace of Star Tiger was ever found. No wreckage, no life rafts, no survivors. The disappearance launched one of the most intensive aviation investigations in British history, but the mystery has never been solved. 10. Star Ariel's identical fate. Just over a year after Star Tiger's disappearance, British aviation was struck by an almost identical tragedy when Star Ariel vanished on January 17, 1949, carrying 20 people from Bermuda toward Jamaica. Captain John McPhee commanded this Avro Tudor 4 aircraft, the same model that had disappeared so mysteriously the previous year. The flight began normally, with Star Ariel maintaining regular radio contact as it departed Bermuda's airspace and headed southwest toward its Caribbean destination. Weather conditions were favorable, and the aircraft was performing within all normal parameters when it suddenly fell silent. Ground controllers waited anxiously for the scheduled radio check-in, but the airways remained eerily quiet. Star Ariel had simply vanished, just as Star Tiger had done 13 months earlier. The loss of two identical aircraft under nearly identical circumstances sent shock waves through the aviation industry. British investigators found themselves facing the impossible task of explaining how two modern aircraft, operated by experienced crews, could disappear so completely in the same general area. The Star Ariel disappearance cemented the region's growing reputation as a place where aircraft simply vanished without explanation. 11. The flawed flying machines. Both Star Tiger and Star Ariel were Avro Tudor 4 aircraft, a British design that harbored serious engineering flaws that would eventually contribute to understanding their mysterious disappearances. The Tudor 4 was an ambitious post-war design intended to compete with American aircraft in the growing international aviation market. However, the aircraft suffered from significant problems with fuel system reliability, pressurization issues, and structural weaknesses that made it vulnerable under certain flight conditions. British aviation authorities had documented numerous concerns about the Tudor IV's performance, including problems with fuel consumption calculations that could leave aircraft dangerously low on fuel during long oceanic flights. The aircraft's electrical systems were also prone to failure, which could disable critical navigation and communication equipment during flight. Pressurization problems meant that crews might face emergency situations that required rapid descents, potentially putting the aircraft in dangerous configurations. These design flaws, combined with the challenging conditions of oceanic flying in the 1940s, created a perfect storm of factors that could explain the aircraft's disappearances. The Tudor IV was eventually withdrawn from service, but not before claiming the lives of those aboard Star Tiger and Star Ariel. 12. The official British conclusion. After extensive investigations into both Star Tiger and Star Ariel disappearances, British aviation authorities reached a conclusion that would haunt investigators for decades. Through lack of evidence due to no wreckage having been found, the cause of the accident is unknown. This official statement represented one of the most frustrating conclusions in aviation history. Despite deploying significant resources, interviewing countless witnesses, and analyzing every available piece of evidence, investigators simply could not determine what had happened to either aircraft. The lack of physical evidence meant that theories remained just that, theories without the concrete proof needed to solve the mysteries. British investigators examined weather patterns, analyzed fuel consumption data, interviewed ground personnel, and studied similar incidents around the world. They considered every possibility from mechanical failure to pilot error to severe weather encounters. But without wreckage, radio recordings, or survivor testimony, the investigation hit an impenetrable wall of uncertainty. This official admission of defeat would become a template for many future Bermuda Triangle investigations, where the absence of evidence became evidence itself of something extraordinary. 13. The ghost ship of the Outer Banks. The five-masted schooner Carol A. Deering presented one of the most chilling maritime mysteries when it was discovered aground on Diamond Shoals off Cape Hatteras on January 31, 1921. The massive vessel, stretching 255 feet from stem to stern, sat eerily silent on the treacherous shoals with all 11 sails set, but not a soul aboard. Coast Guard personnel who boarded the abandoned ship found a scene that seemed frozen in time. Food was still cooking on the galley stove, personal belongings remained undisturbed in crew quarters, and navigation equipment sat ready for use. But all 10 crew members had vanished without a trace, leaving behind no clues about their fate. The ship's lifeboats were missing, but no bodies or wreckage from them was ever found despite extensive searches. Even more mysteriously, the ship's navigation equipment and crew's personal belongings had been selectively removed, suggesting that whatever happened was not a random act of nature. The Carol A. Deering became known as the ghost ship of the Outer Banks, a haunting reminder that the sea could steal men's lives while leaving their vessels behind as silent witnesses. 14. A federal investigation like no other. The mysterious fate of the Carol A. Deering triggered an unprecedented federal investigation that would involve 5 separate government departments in one of the most comprehensive maritime investigations in American history. Secretary of Commerce Herbert Hoover personally took charge of the investigation, recognizing that the case had implications far beyond a simple maritime accident. The Department of Commerce, Navy Department, Treasury Department, State Department, and Department of Justice all contributed resources to solving the mystery. Investigators examined every aspect of the ship's final voyage, interviewing crew members who had served on previous trips, analyzing cargo manifests, and studying weather patterns from the time of the disappearance. They explored theories ranging from mutiny to piracy to foreign interference, as tensions from World War I still influenced international relations. The investigation team included maritime experts, federal agents, naval intelligence officers, and diplomatic personnel. Despite this unprecedented level of federal attention and resources, the investigation ultimately failed to determine what happened to the Carol A. Deering's crew. The case file grew to thousands of pages, but the mystery remained unsolved, adding to the region's growing reputation for unexplained disappearances. 15. The Lighthouse Keeper's Hoax. Years after the Carol A. Deering investigation had gone cold, a dramatic discovery seemed to offer new hope for solving the mystery, until it was revealed as an elaborate hoax perpetrated by someone with a surprising motive. In 1926, a bottle washed ashore containing a message that claimed to be from the Deering's crew, stating they'd been captured by pirates and taken to a remote location. The message provided specific details about the alleged capture and seemed to offer the first concrete clue about the crew's fate. Federal investigators immediately launched a new investigation, following up on every detail mentioned in the message. However, careful analysis revealed that the message was a forgery written by someone hoping to secure employment as a lighthouse keeper at Cape Hatteras. The hoaxer apparently believed that discovering this crucial evidence would make him a hero and help him land the lighthouse job he desperately wanted. This deception highlighted how the daring mystery had captured public imagination so strongly that people were willing to fabricate evidence to insert themselves into the story. The hoax also demonstrated the challenges investigators faced in separating fact from fiction in high-profile maritime mysteries. 16. The deepest point in the Atlantic. Beneath the surface of the Bermuda Triangle lies one of the most dramatic geological features on Earth, the Milwaukee Depth in the Puerto Rico Trench, which plunges in staggering 27,493 feet below sea level. This underwater chasm represents the deepest point in the entire Atlantic Ocean, creating an abyss so profound that it could swallow Mount Everest with room to spare. The trench formed millions of years ago through tectonic activity, where the oceanic crust buckles and folds under immense geological pressure. At these crushing depths, water pressure reaches over 1,100 times greater than at sea level, creating an environment more hostile than outer space. Any wreckage that falls into these depths becomes virtually impossible to recover, potentially explaining why some triangle disappearances have never yielded physical evidence. The extreme depth variations in the region create complex underwater currents and pressure systems that can affect surface conditions in unpredictable ways. Submarines and deep-sea exploration vehicles require specialized equipment just to survive the journey to these depths. The Milwaukee Depth serves as a reminder that the Bermuda Triangle sits atop some of the most geologically dramatic terrain on the planet. 17. Underground wonders beneath the waves. The seafloor beneath the Bermuda Triangle conceals an extensive network of geological features that reads like an underwater wonderland. 161 identified karst formations, including sinkholes, natural bridges, and cave systems. These limestone formations developed over millions of years as slightly acidic seawater dissolved the calcium carbonate bedrock, creating intricate underground passages and chambers. Some of these underwater caves extend for miles beneath the ocean floor, forming complex networks that could easily hide wreckage or create unexpected currents. Natural bridges span underwater canyons, while sinkholes create sudden depth changes that could pose navigation hazards to vessels operating in shallow water. The karst topography indicates that the region sits atop a foundation that is literally riddled with holes and passages, creating an unstable underwater landscape. These geological features can create localized currents, temperature variations, and even underwater turbulence that affect surface conditions. Marine archaeologists have discovered that some of these cave systems contain fresh water, indicating complex underground hydrology that connects to distant land masses. The presence of so many karst features helps explain why the triangle's underwater terrain is so complex and potentially hazardous to navigation. 18. NOAA's hidden underwater mountains. In 2018, NOAA's deep-sea mapping expedition revealed a startling discovery. Previously unknown seamounts rising over 2,985 feet above the seafloor, creating underwater mountains that had remained hidden from human knowledge for centuries. These massive geological structures, scattered across the triangle's seafloor, represent ancient volcanic activity that shaped the region millions of years ago. The seamounts create complex underwater topography that affects ocean currents, marine life distribution, and potentially surface weather patterns. Some of these underwater mountains rise to within a few hundred feet of the surface, creating navigation hazards that don't appear on standard nautical charts. The discovery required advanced sonar technology and months of careful mapping to reveal the full extent of these hidden features. Each seamount creates its own microecosystem, influencing local currents and serving as a habitat for unique marine species. The existence of uncharted seamounts demonstrates how much about the triangle's underwater landscape remains unknown, even with modern technology. These underwater mountains could have posed serious navigation hazards to historical vessels that lacked modern depth-finding equipment, potentially contributing to some of the region's maritime accidents. 19. The northernmost tropical paradise. The waters around Bermuda host the northernmost coral reef assemblage in the entire Atlantic Ocean, creating a unique tropical ecosystem thriving at the edge of its natural range. These coral reefs represent a biological miracle, surviving and flourishing in water temperatures that should be too cold for tropical coral growth. The Gulf Stream's warm current carries tropical water northward, creating a pocket of Caribbean-like conditions in the middle of the North Atlantic. Brain corals, staghorn corals, and dozens of other tropical species have established thriving colonies that support an incredibly diverse marine ecosystem. The reef system forms a complex barrier around Bermuda's northern coast, creating both natural beauty and significant navigation hazards. These living structures have been growing for thousands of years, building upon layer after layer of coral skeletons to create massive underwater formations. The reefs support over 600 documented fish species, making the triangle one of the most biodiverse marine regions in the North Atlantic. However, this same biological richness that makes the area special also creates numerous underwater obstacles that have claimed hundreds of vessels throughout history. 20. A graveyard of ships. The coral reefs surrounding Bermuda have created one of the highest concentrations of shipwrecks per square mile anywhere in the world, with over 300 documented vessels lost on these treacherous formations since the 1600s. These reefs, while biologically magnificent, have acted as silent sentinels of destruction for centuries, claiming vessels from Spanish galleons to modern cargo ships. The shallow, sharp coral formations can tear through ship hulls like razors, often causing catastrophic damage before crews realize they've run aground. Many of these wrecks occurred during storms when vessels were driven onto the reefs by powerful winds and currents. The clear, warm water has preserved many of these shipwrecks in remarkable condition, creating an underwater museum of maritime history. Divers regularly explore these artificial reefs, which have become home to countless marine species over the centuries. The concentration of shipwrecks is so dense that marine archaeologists estimate many more remain undiscovered, buried beneath sand and coral growth. These historical losses demonstrate that the Triangle's reputation for claiming vessels has real basis in documented maritime accidents, even if the causes were natural rather than supernatural. 21. The sea without shores. The Bermuda Triangle sits within the unique boundaries of the Sargasso Sea, the only sea on Earth that is defined not by land masses, but by the circular currents that surround it. This massive body of water, roughly the size of the continental United States, exists as a distinct marine ecosystem suspended in the middle of the Atlantic Ocean. The Sargasso Sea has no coastlines, no beaches, no continental boundaries. It is literally a sea within a sea, created and maintained entirely by ocean currents. The circular motion of these currents traps floating materials, including the distinctive sargassum seaweed that gives the sea its name. Christopher Columbus wrote about these strange floating meadows of seaweed during his historic voyages, describing water so thick with vegetation that it seemed like solid land. The unique nature of the Sargasso Sea creates unusual conditions for navigation, with water that behaves differently from normal ocean environments. Currents can be unpredictable, and the massive quantities of floating seaweed can clog ship propellers and navigation equipment. This extraordinary marine environment adds another layer of complexity to understanding the Triangle's influence on maritime and aviation activities. 22. The Circular Current Prison. For major ocean currents, the Gulf Stream, North Atlantic Current, Canary Current, and North Equatorial Current combine to form the North Atlantic Gyre, effectively creating a circular prison of moving water around the Sargasso Sea. This massive oceanic circulation system moves clockwise, trapping everything within its boundaries in a slow but relentless circular motion. The gyre acts like a giant washing machine, slowly stirring the water and everything floating within it around and around for years or even decades. Debris, seaweed, and even marine life become trapped within this circular current system, unable to escape to other parts of the Atlantic Ocean. The circular motion affects weather patterns, water temperature, and marine ecosystems in ways that scientists are still working to understand. Navigation within the gyre can be challenging because currents don't move in straight, predictable lines but follow complex circular and spiral patterns. Ships and aircraft operating in this region must account for the gyre's influence on their movement and fuel consumption. The North Atlantic Gyre represents one of the largest circular current systems on Earth, demonstrating the immense forces of nature that operate within the triangle's boundaries. 23. Crystal clear depths. The waters within the Bermuda Triangle possess extraordinary clarity, with underwater visibility extending up to 200 feet in many areas, far exceeding the clarity found in most other ocean regions. This exceptional visibility results from the unique characteristics of the Sargasso Sea, where the circular current system filters and purifies the water over long periods. The lack of continental runoff means that sediment and pollutants that cloud other coastal waters are absent from this mid-ocean environment. Divers and underwater photographers consider these waters among the clearest in the world, offering views of the seafloor at depths that would be impossible in most other locations. This crystal clarity has both benefits and dangers for mariners. While it allows for excellent visibility of underwater hazards like coral reefs, it can also create optical illusions that make depth perception difficult. The clear water can make underwater objects appear much closer to the surface than they actually are, potentially leading navigation errors. Sunlight penetrates much deeper than normal in these waters, creating unique underwater lighting conditions that can affect marine life behavior and navigation. The extraordinary clarity serves as another reminder that the Triangle's marine environment possesses characteristics that set it apart from typical ocean conditions. 24. Centuries of seismic violence. The Bermuda Triangle region has experienced 56 documented earthquakes over the past 350 years, revealing a geological instability that contradicts the area's reputation as a stable mid-ocean platform. These seismic events demonstrate that the region sits atop an active geological zone, despite being located far from traditional earthquake-prone areas like tectonic plate boundaries. The earthquakes range from minor tremors to major events capable of generating tsunamis and affecting surface conditions across hundreds of miles. Underwater earthquakes can create sudden changes in ocean depth, generate powerful underwater currents, and trigger landslides on the steep underwater slopes that characterize the region. The seismic activity indicates ongoing geological processes beneath the ocean floor, including volcanic activity, fault movement, and crustal adjustment. Some of these earthquakes have been powerful enough to affect navigation equipment, damage underwater cables, and create temporary changes in local magnetic fields. The geological instability adds another layer of natural hazard to a region already known for complex weather patterns and challenging navigation conditions. Modern seismic monitoring helps predict and track these events, but historical earthquakes occurred without warning, potentially contributing to some unexplained maritime incidents. 25. The Great Quake of 1664. On December 18, 1664, Bermuda was struck by a devastating earthquake with an estimated magnitude of 6.3 that caused significant damage across the island and sent shock waves throughout the Triangle region. Contemporary accounts describe buildings collapsing, church bells ringing spontaneously, and the ground opening in several locations as the powerful tremor shook the islands. The earthquake was felt across a vast area, with reports of tremors reaching ships at sea and coastal areas hundreds of miles away. This historic event demonstrated that the Triangle region was capable of producing major seismic events with far-reaching consequences. The 1664 earthquake preceded the development of modern seismic measurement tools, so magnitude estimates are based on damage reports and historical accounts. Survivors describe the sound as like thunder underground, and reported that the shaking lasted for several terrifying minutes. The earthquake caused landslides, damaged coral reefs, and may have altered underwater topography in ways that affected navigation for years afterward. This powerful seismic event serves as a reminder that natural forces within the triangle have been shaping the region's character for centuries, long before the area became famous for mysterious disappearances. 26. The tsunami-generating earthquake of 1817. On January 4th, 1817, a massive earthquake with an estimated magnitude of 7.4 struck the Triangle region with such force that it generated a tsunami that traveled over 1,000 miles to reach Delaware Bay. This extraordinary seismic event represents one of the most powerful earthquakes ever recorded in the North Atlantic, demonstrating the region's capacity for geological violence. The tsunami created by this earthquake was observed and documented by witnesses along the entire eastern seaboard of the United States. Wave heights reached several feet as the tsunami propagated northward, causing flooding and damage in coastal areas far from the earthquake's epicenter. Ships at sea reported feeling the earthquake as a powerful underwater explosion, followed by unusual wave patterns that persisted for hours. The 1817 earthquake triggered underwater landslides, altered seafloor topography, and may have created new underwater hazards that affected navigation for decades. Scientific analysis of this historic event has revealed that the Triangle region sits atop geological structures capable of producing earthquakes powerful enough to affect the entire Western Atlantic. The tsunami generated by this earthquake demonstrated how geological events in the Triangle can have consequences that extend far beyond the region's traditional boundaries. 27. Unusually warm waters. The Bermuda Triangle region experiences water temperatures that are significantly warmer than other areas at similar latitudes, creating unique oceanographic conditions that affect everything from weather patterns to marine life. The Gulf Stream carries tropical water from the Caribbean northward through the Triangle, maintaining temperatures that can be 10 to 15 degrees warmer than surrounding ocean areas. These elevated temperatures create a pocket of tropical conditions in the middle of the North Atlantic, supporting coral reefs and marine species that normally couldn't survive at such northern latitudes. The warm water also affects atmospheric conditions, creating unstable air masses that can lead to rapid weather changes and severe storm development. Evaporation rates are higher in these warm waters, adding moisture to the atmosphere and contributing to the formation of fog, clouds, and precipitation. The temperature differential between the warm Triangle waters and surrounding cooler ocean areas creates complex current systems and pressure gradients. These thermal anomalies can affect navigation equipment, radio propagation, and even compass readings in subtle but measurable ways. The unusually warm waters represent another factor that sets the Triangle apart from typical North Atlantic conditions, contributing to its unique character and potentially hazardous navigation environment. 28. Hidden limestone labyrinths. Beneath the water surrounding Bermuda lies an intricate network of limestone formations that includes extensive underwater cave systems extending to depths of 60 to 200 meters below the surface. These limestone structures formed over millions of years as coral reefs died and were compressed into solid rock, creating a foundation riddled with passages, chambers, and voids. The cave systems are so extensive that marine geologists believe they may connect Bermuda to underwater limestone formations hundreds of miles away. Some of these caves contain fresh water, indicating complex underground hydrology that defies conventional understanding of island water systems. The limestone formations create unique acoustic properties underwater, potentially affecting sonar readings and underwater communication systems. Cave-ins and structural collapses in these formations can create sudden depth changes, underwater avalanches, and localized tsunami-like waves. The complex three-dimensional structure of these limestone labyrinths makes accurate depth mapping extremely difficult, even with modern sonar technology. These hidden geological features represent potential navigation hazards that may not appear on standard nautical charts, particularly for vessels operating in shallow water areas around Bermuda. 29. The coral barrier. A 1.5-kilometer wide rim of living coral reef encircles Bermuda's northern islands, creating both a natural breakwater and a formidable navigation hazard that has challenged mariners for centuries. This barrier reef represents thousands of years of coral growth, with countless generations of coral polyps building upon their ancestor skeletons to create a massive living wall. The reef system extends both above and below the waterline, with some sections visible at low tide, while others lurk just beneath the surface. Navigation through the reef requires intimate knowledge of local conditions, tide schedules, and the location of the few safe passages that allow larger vessels to approach Bermuda. The coral formations are sharp enough to slice through ship hulls, and the complex underwater topography can trap vessels that venture too close. Storm waves breaking over the reef can create dangerous conditions that make rescue operations extremely difficult or impossible. The reef serves as a natural laboratory for marine biologists, supporting an incredibly diverse ecosystem that includes tropical fish species at the northern limit of their range. This coral barrier demonstrates how natural beauty and navigational danger often go hand in hand in the Triangle region. 30. The magnetic field mystery solved. Extensive magnetic field testing conducted by the U.S. Navy across the Bermuda Triangle region has definitively proven that no significant local magnetic disturbances exist in the area, debunking one of the most persistent theories about the triangle's mysterious properties. Navy researchers deployed sensitive magnetometers across thousands of square miles of ocean, measuring magnetic field strength and variation with precision instruments capable of detecting even minor anomalies. The comprehensive testing revealed that magnetic field readings throughout the triangle fall within normal parameters for the North Atlantic region. Any magnetic variations that do exist are consistent with the Earth's natural magnetic field fluctuations and pose no threat to navigation equipment. The testing included measurements taken at various depths, altitudes, and times of day to account for any possible temporal or spatial variations in magnetic conditions. These scientific findings directly contradict popular theories that attribute triangle disappearances to magnetic anomalies that interfere with compass and navigation systems. The Navy's conclusions have been verified by independent scientific institutions and magnetic surveys conducted by civilian research organizations. This definitive debunking of magnetic anomaly theories represents one of the clearest examples of how scientific investigation can dispel supernatural explanations for triangle phenomena. 31. The compass confusion solved. The historical alignment of magnetic north and true north in the Bermuda Triangle region, which once caused compass confusion for navigators, ceased to exist in the 19th century due to natural changes in Earth's magnetic field. During earlier centuries, the Triangle region was crossed by an agonic line, a location where magnetic declination equals 0, meaning that magnetic compasses pointed toward true north without requiring correction. This unusual condition could cause navigation problems for pilots and ship captains who failed to account for compass variation, potentially leading them off course. However, the Earth's magnetic field is constantly shifting, and the agonic line has moved far from the Triangle region over the past 200 years. Modern navigation charts clearly indicate magnetic declination for every location, allowing navigators to make precise corrections for the difference between magnetic and true north. GPS technology has largely eliminated reliance on magnetic compasses for primary navigation, reducing the possibility of compass-related navigation errors. The historical compass confusion phenomenon provides a rational explanation for some navigation difficulties experienced by early aviators and mariners in the region. This natural change in magnetic conditions demonstrates how some triangle mysteries have logical explanations rooted in geological and navigational science. 32. The real magnetic anomaly. The nearest significant magnetic anomaly to the Bermuda Triangle is actually located over 1,000 miles away off the coast of Brazil, completely outside the Triangle's traditional boundaries. This Brazilian magnetic anomaly represents a genuine geological feature where unusual concentrations of magnetic minerals create measurable disturbances in compass readings and navigation equipment. Scientists have thoroughly mapped this South American anomaly, documenting its effects on both maritime and aviation navigation systems. The distance between this real magnetic anomaly and the Bermuda Triangle conclusively demonstrates that magnetic disturbances cannot explain triangle disappearances. Oceanographic surveys using sensitive magnetic detection equipment have confirmed the absence of similar anomalies within the Triangle region. The Brazilian anomaly serves as an example of what a genuine magnetic disturbance looks like and how it affects navigation, conditions that simply don't exist in the Triangle. This geographical separation between real magnetic anomalies and the Triangle region provides clear scientific evidence against magnetic theories for Triangle mysteries. The identification of the true location of magnetic anomalies helps separate fact from fiction in discussions about unusual magnetic properties in the Atlantic Ocean. 33. The methane mystery debunked. The U.S. Geological Survey has conclusively determined that no large methane gas releases have occurred in the Bermuda Triangle area for at least the past 15,000 years, debunking theories about methane hydrate eruptions causing ship disappearances. Geological surveys of the seafloor have identified methane hydrate deposits in the region, but these formations show no signs of recent or ongoing release activity. Methane hydrates are ice-like substances that form under specific conditions of high pressure and low temperature on the ocean floor. While laboratory experiments have demonstrated that large methane bubble releases could theoretically reduce water density enough to sink ships, no evidence exists of such events occurring in the Triangle. Sophisticated monitoring equipment would detect any significant methane releases, as these events would leave clear chemical signatures in the water and atmosphere. The 15,000-year timeline represents the entire period of modern human civilization, meaning that no historical Triangle disappearances could be attributed to methane release events. Scientific analysis of sediment cores from the Triangle region shows no evidence of the geological disruption that would accompany major methane release events. This definitive geological evidence removes methane hydrate eruptions from the list of possible explanations for Triangle mysteries. 34. The phantom gas theory. Despite the absence of actual methane releases in the Bermuda Triangle, no evidence has ever been found linking methane hydrate deposits to any of the documented disappearances in the region. Investigators have thoroughly examined each major Triangle incident, looking for any physical or chemical evidence that might indicate methane gas involvement. Methane releases would leave distinctive signatures, changes in water color, unusual bubble formations, chemical residues, and characteristic odors that would be detectable for days or weeks. None of the Triangle disappearances, from Flight 19 to the USS Cyclops, occurred under conditions that would be consistent with large-scale methane release events. Scientific studies of similar methane release events in other parts of the world have established clear criteria for identifying when such events have occurred. Laboratory simulations of methane-induced ship sinking require gas release volumes that would be visible from great distances and detectable by multiple types of monitoring equipment. The complete absence of methane-related evidence in Triangle cases demonstrates that this theory, while scientifically plausible in principle, has no basis in the actual facts of Triangle disappearances. This gap between theoretical possibility and actual evidence illustrates how scientific speculation can be confused with scientific fact in discussions of Triangle phenomena. 35. The river in the ocean. The Gulf Stream flows through the Bermuda Triangle at speeds reaching up to 5.6 miles per hour, creating a powerful river in the ocean that can sweep away wreckage and complicate search and rescue operations. This massive current system transports over 30 million cubic meters of water per second northward along the eastern seaboard of the United States. The Gulf Stream's flow rate is roughly 300 times greater than the Amazon River, making it one of the most powerful current systems on Earth. The current can carry debris hundreds of miles from the location of an incident, potentially explaining why wreckage from some triangle disappearances has never been found. Ships and aircraft operating in Gulf Stream waters must account for the current's effect on their navigation and fuel consumption calculations. The stream's boundaries are not fixed. The current can shift position by dozens of miles, creating unpredictable navigation conditions. Eddies and countercurrents along the stream's edges can create complex flow patterns that make precise navigation extremely challenging. The Gulf Stream's enormous power demonstrates how natural ocean forces within the triangle can affect maritime operations in ways that might seem mysterious to those unfamiliar with oceanographic conditions. 36. Monster waves from nowhere. University of Southampton research has confirmed that the Bermuda Triangle region is susceptible to the formation of rogue waves exceeding 100 feet in height, created when storms from different directions produce destructive wave interference patterns. These monster waves, also called freak waves, can appear suddenly in otherwise moderate sea conditions, rising far above the surrounding wave pattern. Rogue waves form when multiple wave systems moving in different directions converge at a single point, combining their energy into a single massive wall of water. The triangle's position makes it particularly vulnerable to these events because storm systems from the Atlantic, Caribbean, and North American coast can all contribute waves to the same area. Modern oceanographic research has documented rogue waves reaching heights of 80 to 100 feet in the Triangle region, tall enough to overwhelm large ships. Computer simulations show that these waves can form and dissipate within minutes, making them extremely difficult to predict or avoid. Historical accounts from Triangle incidents often mention sudden storms or unusual wave conditions that may actually describe encounters with rogue waves. The existence of documented rogue wave activity provides a natural explanation for some maritime accidents that were previously considered mysterious. 37. Ships snapping like twigs. Laboratory simulations conducted by maritime engineers have demonstrated that large vessels can literally snap in half when suspended between two rogue wave peaks, revealing a catastrophic failure mode that could explain sudden ship disappearances. The physics of this failure mode are terrifyingly simple. When a ship's bow and stern are supported by wave crests while the middle section spans a deep trough, the vessel experiences stresses that exceed its structural limits. Modern cargo ships, despite their impressive size, are designed to be supported by water along their entire length, not to bridge gaps like floating bridges. Computer models show that ships over 400 feet in length are most vulnerable to this type of failure, as their length makes them more likely to span the distance between wave peaks. When structural failure occurs, ships can break apart so quickly that crews have no time to send distress signals or deploy lifeboats. The broken sections of a ship can sink rapidly in deep water, leaving little or no debris on the surface for search teams to find. This phenomenon has been documented in other ocean areas and provides a plausible explanation for ship disappearances that occur without distress calls or wreckage recovery. The rogue wave theory demonstrates how natural forces can create conditions that seem supernatural to those who don't understand the underlying physics. 38. Size matters in survival. Counterintuitively, maritime research has revealed that larger ships are actually more vulnerable to rogue wave destruction than smaller vessels, which can often ride over extreme waves that would destroy bigger ships. Small boats and yachts have the ability to surf over large waves, using their light weight and maneuverability to avoid the most dangerous aspects of extreme sea conditions. Large ships, by contrast, cannot change direction quickly enough to avoid rogue waves and lack the flexibility to bend with extreme wave motion. The physics of wave interaction change dramatically with vessel size. What represents a survivable challenge for a small boat can become a death sentence for a large ship. Historical analysis of Triangle incidents shows that many unexplained disappearances involved large vessels, while smaller craft often survived similar conditions. This size-vulnerability relationship helps explain why some Triangle incidents involve the complete loss of large, well-equipped vessels, while smaller boats in the same area escaped unharmed. The relationship between vessel size and wave vulnerability demonstrates that bigger is not always better when it comes to surviving extreme ocean conditions. Understanding this principle helps explain how natural forces can selectively affect different types of vessels in the same area. 39. Confirming the wave theory. Independent research conducted by the University of Southampton has provided scientific confirmation that the Bermuda Triangle region experiences wave conditions extreme enough to pose genuine threats to surface vessels. The university's oceanographic studies used advanced wave monitoring equipment and computer modeling to analyze wave patterns throughout the Triangle region. Their research documented multiple instances of wave heights exceeding 60 feet during storm conditions, with some events producing waves over 80 feet high. The study confirmed that the Triangle's position makes it a natural convergence zone for multiple storm systems, increasing the likelihood of extreme wave formation. Mathematical models developed by the university demonstrate how waves from Caribbean storms, Atlantic hurricanes, and North American weather systems can combine in the Triangle area. The research team used satellite imagery, weather data, and ocean buoy measurements to validate their theoretical predictions about wave formation. Their findings provide scientific support for the theory that extreme waves, rather than supernatural forces, may explain some historical Triangle incidents. This academic validation of extreme wave theory represents a significant step forward in developing rational explanations for Triangle phenomena. 40. Triangle safety statistics revealed. The comprehensive 2013 World Wildlife Fund study of global shipping lanes delivered a surprising verdict. The Bermuda Triangle ranked only 12th out of 35 analyzed areas in total shipping losses, definitively debunking claims that it represents the world's most dangerous waters. This extensive analysis examined shipping incident data from maritime insurance companies, Coast Guard records, and international shipping organizations covering several decades of global maritime activity. The study evaluated 35 major shipping corridors around the world, including areas known for severe weather, heavy traffic, and challenging navigation conditions. The Triangle's 12th place ranking puts it well outside the top 10 most dangerous shipping areas, contradicting decades of sensationalized media coverage. Areas that ranked higher for shipping losses included the North Sea, Mediterranean shipping lanes, and several Asian coastal corridors with much higher incident rates. The statistical analysis included factors such as shipping volume, weather conditions, and the severity of incidents when calculating danger rankings. This objective, data-driven approach provides a clear scientific perspective that contradicts popular perceptions about Triangle dangers. The WWF study represents one of the most comprehensive attempts to quantify maritime danger using actual incident data rather than anecdotal evidence. 41. Even safer by density. The same World Wildlife Fund analysis that ranked the Bermuda Triangle 12th in total shipping losses placed it even lower, 22nd out of 35 areas, when measuring loss density per square kilometer, indicating that the Triangle is actually safer than most major shipping areas when its size is considered. This density calculation provides a more accurate measure of relative danger because it accounts for the Triangle's large area compared to narrower shipping corridors. The per square kilometer analysis reveals that many smaller, more confined shipping areas experience much higher concentrations of maritime incidents. Coastal shipping lanes, harbor approaches, and narrow straits consistently showed higher incident densities than the open ocean areas that characterize most of the Triangle. The density measurement methodology eliminates bias that might favor smaller areas with less total shipping activity. The 22nd place density ranking demonstrates that the Triangle's incident rate is actually below average for major maritime corridors. This statistical evidence directly contradicts popular beliefs about the Triangle representing an unusually dangerous area for shipping. The density analysis provides scientific validation that the Triangle's reputation for danger is not supported by actual maritime safety data. 42. Coast Guard records tell the truth. Analysis of over 150,000 U.S. Coast Guard Marine casualty records covering the 33-year period from 1982 to 2015 revealed only 361 reported incidents within the Bermuda Triangle boundaries, a remarkably low number for such a heavily trafficked area. This comprehensive database represents the most complete record of maritime incidents available for the Triangle region, covering everything from minor mechanical failures to major disasters. The 361 incidents spread over 33 years averages to fewer than 11 incidents per year in an area that sees thousands of vessel transits annually. The Coast Guard database includes detailed information about the cause, severity, and outcome of each incident, allowing for precise analysis of actual maritime dangers. The relatively small number of incidents demonstrates that the Triangle is actually one of the safer areas for maritime operations in the Western Atlantic. Many other coastal areas with similar shipping volumes show significantly higher incident rates in the same Coast Guard database. The 33-year time frame provides enough data to identify trends and rule out statistical anomalies that might skew shorter-term studies. This official government data provides an authoritative counterpoint to sensationalized claims about Triangle dangers. 43. No mysterious disappearances found. Perhaps most significantly, the comprehensive analysis of U.S. Coast Guard Marine casualty records from 1982 to 2015 found that 0 incidents in the Bermuda Triangle were classified as disappearance, completely contradicting the area's reputation for mysterious vanishings. The Coast Guard's classification system includes specific categories for different types of maritime incidents, with disappearance reserved for cases where vessels vanish without explanation. Every one of the 361 recorded Triangle incidents had a documented cause: mechanical failure, weather damage, operator error, collision, or other identifiable factors. The absence of mysterious disappearances in the modern era suggests that improved technology and safety procedures have eliminated the conditions that may have contributed to historical incidents. This finding demonstrates a clear pattern. As navigation technology, communication systems, and safety equipment have improved, mysterious disappearances have essentially ceased. The Coast Guard data covers the era of GPS navigation, satellite communication, and modern emergency beacons, technologies that make unexplained disappearances virtually impossible. The 0 disappearance rate in recent decades provides strong evidence that historical Triangle mysteries resulted from technological limitations rather than supernatural causes. This data represents the most definitive evidence available that the Triangle poses no special threat to modern maritime operations. 44. Insurance companies aren't worried. Lloyd's of London, the world's leading maritime insurance market, does not charge higher premiums for vessels transiting the Bermuda Triangle, providing definitive proof that professional risk assessors see no unusual danger in the region. Insurance companies base their premium calculations on extensive actuarial analysis of actual risk factors, using decades of claims data to identify genuinely dangerous areas. Lloyd's risk assessment methodology includes analysis of weather patterns, traffic density, navigation hazards, and historical loss rates when setting premium levels. Areas that pose elevated risks, such as piracy zones, severe weather corridors, or regions with poor navigation aids, consistently show higher insurance rates. The fact that Triangle Transit carries no premium penalty indicates that insurers see the region as no more dangerous than other heavily traveled ocean areas. Marine insurance underwriters have access to the most comprehensive maritime incident databases in the world, making their risk assessments extremely reliable. The insurance industry's collective judgment represents billions of dollars in potential liability, ensuring that risk assessments are based on hard data rather than popular mythology. This market-based validation provides an economic perspective that strongly contradicts supernatural theories about Triangle dangers. 45. The experience or statistical analysis reveals that 82% of maritime incidents in the Bermuda Triangle involve inexperienced operators, a rate that is consistent with recreational boating areas throughout the United States, indicating that operator error rather than mysterious forces explains most Triangle accidents. This high percentage of inexperience-related incidents reflects the Triangle's popularity as a recreational boating destination, attracting many weekend sailors and amateur navigators. The 82% figure matches or exceeds inexperience rates in other popular recreational boating areas, such as the Florida Keys, Chesapeake Bay, and coastal New England waters. Inexperienced operators are more likely to make navigation errors, misjudge weather conditions, or operate their vessels beyond safe limits. The consistency of this percentage across different recreational boating areas demonstrates that the Triangle poses no special challenges beyond those faced by inexperienced mariners everywhere. Professional mariners and experienced recreational boaters show much lower incident rates in Triangle waters, indicating that knowledge and skill are the primary factors in safe navigation. This statistical pattern provides clear evidence that human factors, not supernatural forces, account for the majority of Triangle maritime incidents. The experience factor helps explain why the Triangle's reputation for danger is largely based on incidents involving operators who lack the skills to handle challenging but normal ocean conditions. 46. Official Coast Guard position. The United States Coast Guard has issued an official position statement declaring that it does not recognize the existence of the so-called Bermuda Triangle as a geographic area of specific hazardous ships or planes, representing the definitive government position on Triangle dangers. This official statement is based on decades of Coast Guard operations in the region, including thousands of search and rescue missions and continuous monitoring of maritime safety conditions. The Coast Guard's position reflects analysis of their own operational data, maritime incident reports, and coordination with other government agencies involved in Triangle research. As the federal agency responsible for maritime safety in U.S. waters, the Coast Guard has access to the most comprehensive safety data available for the Triangle region. The statement specifically addresses popular concerns about supernatural or unusual dangers, concluding that no evidence supports such claims. Coast Guard personnel who work in the Triangle region on a daily basis report no unusual phenomena or elevated danger levels compared to other ocean areas. This official government position provides authoritative contradiction to sensationalized media claims about Triangle hazards. The Coast Guard statement represents the consensus view of the federal agencies most qualified to assess maritime safety in the Triangle region. 47. Human error is the real culprit. The Coast Guard's comprehensive review of Triangle maritime incidents concluded that casualties result from nothing other than physical causes, with 82% of cases involving inexperienced operators who made preventable errors in judgment or navigation. This finding places Triangle incidents squarely within the realm of normal maritime accidents rather than unexplained phenomena. The physical causes identified by the Coast Guard include mechanical failures, weather damage, navigation errors, fuel exhaustion, and collision with known hazards. The high percentage of inexperience-related incidents demonstrates that proper training and experience are the most effective tools for safe Triangle navigation. Coast Guard investigators found no evidence of unusual electromagnetic effects, supernatural interference, or other extraordinary factors in any Triangle incident. The review included analysis of incidents dating back several decades, providing a comprehensive picture of actual versus perceived Triangle dangers. This official conclusion directly contradicts popular theories about mysterious forces affecting vessels and aircraft in the Triangle region. The emphasis on human factors highlights the importance of proper seamanship and navigation skills for safe operation in any challenging marine environment. 48. NOAA's scientific verdict. The National Oceanic and Atmospheric Administration has issued a definitive scientific statement concluding that there is no evidence that mysterious disappearances occur with any greater frequency in the Bermuda Triangle than in any other large, well-traveled area of the ocean. NOAA's conclusion is based on comprehensive analysis of maritime and aviation incident data collected by multiple government agencies over several decades. As the federal agency responsible for ocean and atmospheric research, NOAA has access to the most complete environmental and safety databases available for the Triangle region. The agency's statement specifically addresses popular claims about unusual disappearance rates, finding no statistical support for such assertions. NOAA's analysis includes comparison of triangle incident rates with other heavily traveled ocean areas, revealing no significant differences in safety statistics. The scientific methodology used by NOAA includes peer review and verification by independent researchers, ensuring the reliability of their conclusions. This official scientific position represents the consensus view of the federal government's most qualified ocean research agency. NOAA's statement provides authoritative contradiction to decades of sensationalized media coverage about triangle mysteries. 49. The world's busiest waters. The Bermuda Triangle region ranks among the most heavily traveled shipping lanes in the world, with thousands of commercial and recreational vessels navigating its waters daily, making it a statistically normal location for maritime incidents to occur. This heavy traffic includes major shipping routes connecting North America with Europe and South America, creating one of the busiest maritime corridors on Earth. Cruise ships, cargo vessels, fishing boats, pleasure craft, and military ships all operate regularly within triangle boundaries. The high traffic volume means that even a normal incident rate will produce a significant absolute number of accidents and emergencies. Commercial shipping routes through the triangle carry millions of tons of cargo annually, representing a significant portion of international maritime trade. The region's popularity as a recreational boating and fishing destination adds thousands of additional vessel movements each year. Aviation traffic is equally heavy, with major air routes connecting North America to the Caribbean and South America passing through triangle airspace. This intense activity level provides context for understanding why the triangle appears in maritime incident statistics. It's simply one of the busiest areas on the ocean. 50. Aviation statistics match global patterns. Modern aviation incident data collected by the National Transportation Safety Board shows that aircraft accident patterns in the Bermuda Triangle region closely mirror worldwide aviation safety statistics, with no unusual characteristics specific to the triangle area. The NTSB database includes detailed analysis of all aviation incidents in triangle airspace over several decades, providing comprehensive safety statistics. Accident rates per flight hour in triangle airspace fall within normal parameters for similar high-traffic aviation corridors worldwide. The causes of triangle aviation incidents, weather, mechanical failure, pilot error, match the global distribution of accident causes in commercial and general aviation. No unusual patterns of navigation equipment failure, radio communication loss, or other phenomena associated with triangle mythology appear in the statistical data. The triangle's position as a major aviation corridor means that it experiences significant air traffic volume, making occasional incidents statistically inevitable. Modern aviation safety equipment and procedures have reduced accident rates in triangle airspace consistent with global aviation safety improvements. This statistical normality provides strong evidence against theories about unusual dangers or mysterious forces affecting aircraft in the Triangle region. 51. The greatest search in military history. The search operation launched for Flight 19 became one of the largest air and sea search efforts in military history, demonstrating the unprecedented resources deployed to solve what would become the Triangle's most famous mystery. The operation involved multiple branches of the U.S. military, Coast Guard units, and civilian volunteers in a coordinated effort spanning 5 days and covering 300,000 square miles. Over 300 aircraft participated in the search, including every available plane from bases throughout Florida and the Caribbean. Surface vessels ranging from Coast Guard cutters to private fishing boats joined the search, creating one of the largest maritime rescue efforts ever mounted. The operation consumed enormous resources, including tens of thousands of gallons of aviation fuel and hundreds of thousands of man-hours. Military personnel worked around the clock in rotating shifts to maintain continuous search coverage across the vast search area. Weather aircraft flew dangerous missions through storm systems to ensure that no area was left unchecked. The unprecedented scale of this search effort reflects both the military's commitment to finding the missing airmen and the seriousness with which authorities treated the disappearance. 52. Blame, guilt, and official revision. The official U.S. Navy report on Flight 19 was dramatically amended from initially blaming pilot error to stating cause unknown after the flight leader's family mounted a successful protest against the original findings. The original Navy investigation concluded that Lieutenant Taylor had become disoriented and led his flight away from land until fuel exhaustion caused all 5 aircraft to crash at sea. Taylor's family challenged this conclusion, arguing that their son was an experienced pilot who would not have made such a fundamental navigation error. The family's protest included testimony from other pilots who knew Taylor's capabilities and character, disputing the pilot error theory. Under pressure from the family and growing public interest in the case, Navy officials agreed to revise their findings to the more ambiguous cause unknown. This revision transformed Flight 19 from a case of pilot error into an unsolved mystery, inadvertently contributing to the Triangle's supernatural reputation. The Board for the Correction of Naval Records eventually cleared Lieutenant Taylor of blame, but maintained that the loss resulted from navigational error and fuel exhaustion. This official revision demonstrates how administrative decisions and family pressure can influence the historical record of Triangle incidents. 53. Cold War naval operations. The U.S. Navy maintained Naval Air Station Bermuda from 1940 to 1995 as a critical Cold War facility for tracking Soviet submarines and protecting vital Atlantic shipping lanes from underwater threats. NAS Bermuda served as a key listening post in the Atlantic, using advanced sonar and surveillance equipment to monitor submarine activity throughout the Triangle region. The facility housed anti-submarine warfare aircraft, including long-range patrol planes equipped with sophisticated detection equipment. During the Cold War's peak, NAS Bermuda coordinated with other NATO facilities to maintain continuous surveillance of Atlantic waters. The base's strategic location made it ideal for intercepting Soviet submarines attempting to monitor U.S. naval operations or approach American coastlines. Naval personnel stationed at Bermuda conducted thousands of flights and patrols throughout the Triangle region without experiencing unusual phenomena. The facility's 55-year operational history provides extensive documentation of normal military operations in the supposedly mysterious Triangle area. The base's closure in 1995 coincided with the end of the Cold War and reduced need for Atlantic submarine surveillance. 54. The Navy's Underwater Area. 51. The Atlantic Undersea Test and Evaluation Center, AUTEC, located on Andros Island, operates as one of the world's most advanced underwater testing facilities, earning it the nickname the Navy's Underwater Area 51 for its secretive submarine and sonar research. AUTEC serves as the primary testing site for U.S. Navy submarine technology, torpedo systems, and underwater detection equipment. The facility operates in waters adjacent to the Bermuda Triangle, conducting classified experiments with advanced underwater vehicles and weapon systems. AUTEC's underwater range covers thousands of square miles of ocean floor, instrumented with sophisticated tracking and monitoring equipment. The center tests new submarine designs, evaluates sonar systems, and trains submarine crews in realistic underwater combat scenarios. Despite conducting thousands of underwater operations in Triangle waters, AUTEC personnel report no unusual phenomena or equipment malfunctions attributable to Triangle effects. The facility's advanced monitoring equipment would detect any unusual electromagnetic, acoustic, or other phenomena if they existed in the region. AUTEC's successful operation for decades provides evidence that even the most sensitive military equipment functions normally in Triangle waters. 55. Secrets revealed, mysteries dissolved. Declassified military documents and Coast Guard records released through Freedom of Information Act requests have provided detailed accounts of Triangle incidents, revealing standard search and rescue operations rather than mysterious cover-ups or extraordinary phenomena. These released documents include operational reports, radio transcripts, weather data, and investigation findings from dozens of triangle incidents. The declassified materials show that military and Coast Guard personnel followed standard emergency response procedures during triangle incidents. No evidence appears in the released documents of unusual equipment failures, unexplained phenomena, or attempts to suppress information about triangle events. The documents reveal the normal challenges faced by search and rescue operations: limited search time, vast ocean areas, and the difficulty of locating small debris fields. Radio transcripts from triangle incidents show normal communication patterns without the mysterious radio interference often claimed in popular accounts. Weather reports included in the declassified files provide rational explanations for many incidents previously attributed to supernatural causes. The transparency demonstrated by these document releases contradicts conspiracy theories about government cover-ups of triangle mysteries. 56. Rescue 21. Modern Search and Rescue. The U.S. Coast Guard's Rescue 21 system has handled over 85,000 search and rescue cases globally since its implementation, providing digital selective calling, direction-finding capability, and enhanced signal clarity that would make mysterious disappearances virtually impossible in modern times. Rescue 21 represents a quantum leap in maritime safety technology, replacing outdated analog radio systems with digital communication networks. The system can automatically determine the location of distress calls with GPS-level accuracy, eliminating the guesswork that characterized historical search operations. Digital selective calling allows mariners to transmit their exact position and vessel information with the push of a button, even if they're unable to speak. Enhanced signal clarity ensures that distress calls can be received and understood even in severe weather conditions that would have made communication impossible in earlier eras. The system's direction-finding capability allows Coast Guard stations to locate vessels even when GPS systems fail or crews are unable to provide position information. Rescue 21's comprehensive coverage includes all areas of the Bermuda Triangle, ensuring that any vessel or aircraft in distress would be immediately located and assisted. The system's remarkable success rate demonstrates how modern technology has eliminated the communication failures that may have contributed to historical triangle mysteries. 57. No statistical evidence of reduced effectiveness. Despite the Bermuda Triangle's reputation for interfering with rescue operations, no statistical evidence exists of reduced search and rescue effectiveness in the Triangle area compared to other ocean regions covered by U.S. Coast Guard operations. Coast Guard search and rescue statistics show normal success rates for Triangle operations, consistent with their performance in other heavily trafficked maritime areas. The agency maintains detailed records of response times, search patterns, and mission outcomes for all geographic areas under their jurisdiction. Triangle search and rescue operations benefit from the region's heavy traffic, which often provides additional vessels to assist in search efforts. The clear water and generally favorable weather conditions in much of the Triangle region actually make search operations easier than in many other Coast Guard operational areas. Modern search techniques, including helicopter operations and satellite surveillance, function normally in Triangle waters without unusual interference or equipment problems. Coast Guard personnel regularly stationed in the Triangle report no operational difficulties or unusual phenomena affecting their missions. The normal effectiveness of search and rescue operations provides strong evidence against theories about electromagnetic or other interference in the Triangle region. 58. Birth of a cultural phenomenon. The term Bermuda Triangle was coined by writer Vincent Gaddis in 1964 in an article published in Argosy magazine, creating the modern name and concept that would capture global imagination for decades to come. Gaddis's article, titled The Deadly Bermuda Triangle, was the first publication to use this specific geographic designation for the region. The article compiled several mysterious disappearances and presented them as evidence of a supernatural danger zone in the Atlantic Ocean. Gaddis drew heavily on earlier maritime mystery stories, but was the first to connect them geographically and give them a memorable name. The Argosy magazine article reached a large popular audience and sparked immediate public interest in the triangle concept. Gaddis's work established many of the themes that would characterize triangle literature for decades: mysterious disappearances, compass malfunctions, and supernatural explanations. The article's success demonstrated public appetite for maritime mystery stories and established a template that other writers would follow and expand upon. This single magazine article essentially created the modern Bermuda Triangle phenomenon, transforming scattered maritime incidents into a cohesive cultural mythology. 59. The first media mention. The earliest media reference to mysterious disappearances in what would become known as the Bermuda Triangle appeared in 1950 when Edward Van Winkle Jones of the Miami Herald wrote about unusual maritime incidents in the region. Jones's article predated Vincent Gaddis's famous Bermuda Triangle piece by 14 years, establishing the foundation for what would become a cultural phenomenon. The Miami Herald article focused on local maritime incidents and presented them as a pattern of mysterious disappearances affecting the South Florida region. Jones's reporting was more journalistic than sensational, focusing on documented incidents rather than supernatural explanations. The article attracted limited attention compared to later Triangle publications, but it established the basic framework of collecting maritime mysteries from a specific geographic area. This early media coverage demonstrates that concern about maritime safety in the region preceded the creation of the modern triangle mythology. Jones's work influenced subsequent writers and researchers who expanded on his initial documentation of mysterious incidents. The progression from Jones's factual reporting to later sensationalized accounts shows how triangle stories evolved from journalism into entertainment. 60. The bestseller that created a legend. Charles Berlitz's 1974 book, The Bermuda Triangle, became a massive international bestseller, selling nearly 20 million copies in 30 languages and single-handedly transforming the triangle from a regional curiosity into a global phenomenon. The book's extraordinary commercial success far exceeded expectations for a work about maritime mysteries, reaching audiences on every continent. Berlitz's work established the triangle as a household name, making it one of the most recognizable geographic concepts in popular culture. The book's translation into 30 languages spread triangle mythology throughout the world, inspiring similar phenomena in other cultures and regions. Sales of 20 million copies made The Bermuda Triangle one of the best-selling nonfiction books of the 1970s. The book's success spawned an entire industry of triangle-related media, including documentaries, TV shows, movies, and countless follow-up publications. Berlitz's work established many of the standard elements of triangle lore that persist in popular culture today. The book's impact on public perception of the triangle demonstrates how a single publication can create and sustain a cultural mythology for decades. 61. Atlantis and aliens enter the picture. Charles Berlitz's influential book explicitly linked Bermuda Triangle disappearances to theories about the lost civilization of Atlantis and extraterrestrial activity, introducing supernatural explanations that would become central to triangle mythology. Berlitz theorized that remnants of Atlantean technology on the ocean floor might be interfering with modern navigation and communication systems. The book suggested that extraterrestrial visitors might be using the triangle area as a base for observing or abducting human beings. These supernatural theories provided dramatic explanations for triangle mysteries that captured public imagination far more effectively than mundane explanations like bad weather or human error. Berlitz's background as a linguist and author of books about unexplained phenomena lent apparent credibility to his supernatural theories. The combination of maritime mystery with ancient civilizations and space aliens created a compelling narrative that appealed to readers interested in the paranormal. These theories established a template that later Triangle authors would follow, emphasizing supernatural rather than scientific explanations. The introduction of Atlantis and alien theories marked the transformation of the Triangle from a navigation hazard into a supernatural phenomenon. 62. The mystery solved by research. Research librarian Larry Kush's meticulous 1975 investigation, documented in his book, The Bermuda Triangle Mystery, Solved, conducted exhaustive research of original sources and conclusively proved that the triangle was a manufactured mystery created by selective reporting and omission of relevant facts. Kush spent months tracking down original newspaper reports, Coast Guard records, and official documents for every major triangle incident. His research revealed that many supposed triangle mysteries had rational explanations that had been omitted from popular accounts. Kush discovered that several famous triangle incidents had actually occurred outside the triangle boundaries or during severe weather conditions. The investigation revealed patterns of exaggeration, misrepresentation, and selective editing in popular triangle literature. Kush's academic approach to triangle research provided a model for scientific investigation of paranormal claims. The book presented side-by-side comparisons of popular triangle accounts with actual documented facts, revealing systematic distortion of evidence. Kush's work demonstrated how rigorous research methodology could dissolve mysteries that had seemed inexplicable in popular accounts. 63. Television debunks the triangle. The 1976 PBS documentary, The Case of the Bermuda Triangle, delivered a devastating critique of supernatural triangle claims, stating that when we've gone back to the original sources or the people involved, the mystery evaporates. This documentary marked the beginning of systematic mainstream media debunking of triangle mythology. PBS researchers independently verified many of Larry Kush's findings, providing additional confirmation that triangle mysteries had rational explanations. The documentary interviewed original participants in triangle incidents, revealing how their accounts had been distorted in popular literature. Expert witnesses included oceanographers, meteorologists, and aviation safety specialists who provided scientific explanations for triangle phenomena. The program's conclusion that the mystery evaporates under investigation became a widely quoted summary of the scientific position on triangle claims. The documentary's credibility was enhanced by PBS's reputation for balanced, fact-based journalism rather than sensationalistic entertainment. This mainstream media debunking marked a turning point in public perception of triangle claims, introducing scientific skepticism to a broader audience. 64. Japan's copycat triangle. The concept of mysterious disappearance zones spread internationally when Japan developed its own version called the Dragon's Triangle, or Mono Umi, following the same cultural template popularized by Charles Berlitz's Bermuda Triangle mythology. The Dragon's Triangle is located in the Pacific Ocean near Japan and is alleged to cause similar mysterious disappearances of ships and aircraft. Japanese writers explicitly modeled their Dragon's Triangle on Berlitz's work, borrowing many of the same themes and supernatural explanations. The Dragon's Triangle demonstrates how the Bermuda Triangle concept became a cultural export, inspiring similar phenomena in other countries. Like the Bermuda Triangle, the Dragon's Triangle lacks scientific evidence for unusual dangers and appears to be a media creation rather than a genuine geographic hazard. The parallel development of these two mystery triangles shows how popular culture can create multiple versions of the same basic mythology. Scientific investigation of the Dragon's Triangle has revealed the same pattern found in Bermuda Triangle research: normal maritime incidents misrepresented as supernatural mysteries. The international spread of triangle mythology demonstrates the global appeal of maritime mystery stories. 65. The 12-Vial Vortices Theory. Scottish biologist Ivan T. Sanderson proposed a theory of 12-Vial vortices located around the world, including the Bermuda Triangle, but this theory lacks any scientific support and has been rejected by the mainstream scientific community. Sanderson claimed that these 12 locations were evenly spaced around the globe and shared similar properties that made them dangerous to navigation. The theory suggested that these vortices were created by some kind of electromagnetic or gravitational anomaly affecting the Earth's surface. Sanderson's biological background lent apparent scientific credibility to his theories, but other scientists found no evidence supporting his claims. The 12 vortices theory has been thoroughly investigated and rejected by geophysicists, oceanographers, and other relevant scientific disciplines. No measurable physical properties distinguish Sanderson's supposed vortex locations from surrounding areas. The theory's equal spacing around the globe appears to be based on geometric speculation rather than actual geographic or physical evidence. Sanderson's work illustrates how superficially scientific theories can gain popular acceptance despite lacking genuine scientific support. 66. GPS eliminates the guesswork. Modern GPS systems provide horizontal position accuracy of better than 3.5 meters globally, including throughout the Bermuda Triangle region, eliminating the navigation uncertainties that may have contributed to historical disappearances. GPS technology represents a revolutionary improvement over the magnetic compass and celestial navigation methods used during the era of most triangle mysteries. The 3.5-meter accuracy standard applies consistently across all ocean areas, with no degradation or special limitations in triangle waters. GPS receivers function normally in the triangle region without interference from alleged electromagnetic anomalies or other mysterious phenomena. The system's satellite constellation provides redundant coverage, ensuring that position fixes remain available even if individual satellites fail. Modern navigation equipment integrates GPS with other systems, providing multiple backup methods for determining position and course. The universal availability of precise navigation has essentially eliminated the possibility of aircraft or vessels becoming lost in the Triangle region. GPS technology demonstrates how advances in navigation capability have solved the fundamental problem that may have caused historical triangle incidents. 67. Emergency beacons provide instant location. GPS-enabled emergency beacons can locate vessels or aircraft in distress within 100 meters of their actual position, providing search and rescue teams with precise coordinates that make mysterious disappearances virtually impossible in the modern era. These emergency position indicating radio beacons, APIRBs, activate automatically when they contact water or can be manually triggered by crews in distress. The 100-meter accuracy represents a dramatic improvement over historical search and rescue operations that often covered thousands of square miles. Modern APIRBs transmit not only position data, but also vessel identification information, allowing Coast Guard responders to know exactly what type of emergency they're responding to. The beacons operate on dedicated emergency frequencies monitored continuously by satellite systems and ground stations. Battery life in modern APIRBs provides days or weeks of continuous transmission, ensuring that rescue teams have extended opportunities to locate emergency sites. The global satellite network that monitors emergency beacons provides coverage even in the most remote ocean areas. This technology makes it essentially impossible for properly equipped vessels or aircraft to disappear without trace in modern times. 68. Gyroscopic compasses eliminate magnetic confusion. Modern gyroscopic compasses are completely unaffected by magnetic field variations, eliminating the compass-related navigation problems that may have contributed to some historical Bermuda Triangle incidents. Gyro compasses operate using the principle of a spinning mass maintaining its orientation in space, making them independent of magnetic influences. Unlike magnetic compasses, gyro compasses point to true geographic north rather than magnetic north, eliminating the need for declination corrections. These instruments maintain their accuracy regardless of the vessel's location on Earth and are unaffected by local magnetic anomalies. Gyro compasses have been standard equipment on commercial vessels and military ships for decades, providing reliable navigation reference. The instruments are typically integrated with other navigation systems, providing redundant heading information for critical operations. Modern gyro compasses include electronic components that can interface with GPS and other navigation systems for enhanced accuracy. The elimination of magnetic compass dependence removes one potential source of navigation error that might have affected historical triangle incidents. 69. Satellite communication everywhere. The International COSPA's SARSAT satellite system provides comprehensive global emergency beacon coverage, ensuring that distress signals from any location on Earth, including the Bermuda Triangle, can be detected and located within minutes. This satellite network represents a cooperative international effort involving multiple countries and space agencies to provide global search and rescue capability. The system operates 24 hours a day, 365 days a year, with multiple satellites providing redundant coverage of all ocean areas. COSPA SARSAT can detect and locate emergency beacons from aircraft, vessels, and personal locator beacons carried by individuals. The system's response time has been reduced to under 10 minutes in many cases, providing almost immediate notification of emergency situations. Satellite coverage includes polar regions and other remote areas where no other communication systems operate effectively. The international cooperation that makes COSPA's SARSAT possible demonstrates the global commitment to maritime and aviation safety. This comprehensive satellite coverage makes it virtually impossible for properly equipped vessels or aircraft to disappear without immediate detection and location. 70. Instant emergency response. GPS-enabled APIRBs can alert search and rescue authorities within 2 to 3 minutes of activation, providing response times that would have seemed miraculous during the era of most Bermuda Triangle mysteries. This rapid response capability results from the integration of GPS positioning with satellite communication systems and automated ground processing. The 2 to 3 minute response time includes signal detection, position calculation, and notification of appropriate rescue coordination centers. Automated systems eliminate human processing delays that characterized earlier emergency communication methods. Modern APIRBs include unique identification codes that immediately provide rescue authorities with information about the vessel or aircraft in distress. The rapid response time allows search and rescue teams to begin deployment while emergency situations are still developing rather than hours after incidents occur. Satellite technology enables this instant communication even from the most remote ocean locations where radio communication would be impossible. The dramatic improvement in emergency response time demonstrates how technology has transformed maritime safety in the Triangle region. 71. TCAS prevents mid-air collisions. Traffic Collision Avoidance System, TCAS, technology monitors airspace up to 40 miles radius around equipped aircraft, providing automated collision avoidance that eliminates the risk of unexplained aircraft disappearances due to mid-air collisions. TCAS operates independently of ground-based air traffic control, providing onboard collision avoidance capability even in remote oceanic areas. The 40-mile monitoring radius provides sufficient time for aircraft to take evasive action even at high closing speeds. The system provides both visual and audio warnings to pilots, with recommended avoidance maneuvers calculated automatically. TCAS has dramatically reduced the incidence of mid-air collisions in commercial aviation since its mandatory implementation. The system operates in all weather conditions and does not depend on visual contact between aircraft. TCAS technology provides collision avoidance capability in oceanic areas where traditional radar coverage is not available. This automated safety system eliminates one potential cause of aircraft disappearances that might have affected historical Triangle incidents. 72. Real-time aircraft tracking. Automatic Dependent Surveillance Broadcast, ADSB. Technology provides GPS-based aircraft position reporting multiple times per second, offering tracking accuracy that exceeds traditional radar systems and makes unexplained aircraft disappearances virtually impossible. ADSB transmits precise position, altitude, and velocity information continuously, providing air traffic controllers with real-time aircraft monitoring. The system updates aircraft positions several times per second, compared to traditional radar systems that update every few seconds. ADSB coverage extends to oceanic areas where traditional radar coverage is not available, including most of the Bermuda Triangle region. The technology provides controllers with aircraft identification, position, and flight plan information automatically. ADSB enables reduced separation standards for aircraft, allowing more efficient use of airspace while maintaining safety. The system operates independently of ground-based infrastructure, making it reliable even during equipment failures or power outages. This comprehensive aircraft tracking capability ensures that any aircraft disappearance would be immediately detected and precisely located. 73. Integrated navigation systems. Electronic chart display and information systems, ECDIS, integrate GPS positioning with radar plotting aids and automatic tracking capabilities, providing comprehensive navigation support that eliminates the uncertainties that may have contributed to historical triangle incidents. ECDIS displays real-time vessel position on electronic nautical charts, showing the relationship between the vessel and all surrounding hazards. The system can plot courses automatically, calculate arrival times, and warn of potential navigation hazards along planned routes. Integration with radar systems provides automatic tracking of other vessels, enhancing collision avoidance capability. ECDIS maintains continuous logs of vessel position and course, providing complete navigation records for later analysis. The system can store multiple chart sets, providing backup navigation capability if primary charts are damaged or lost. Automatic position plotting eliminates human error in navigation calculations and chart plotting. ECDIS represents the integration of multiple navigation technologies into a single, comprehensive system that far exceeds the capability of historical navigation methods. 74. Weather radar coverage. The Bermuda Airport Authority operates dedicated weather radar, providing real-time coverage of weather conditions throughout the Triangle region, giving pilots and mariners advance warning of dangerous conditions that might have surprised earlier travelers. This radar system provides continuous monitoring of precipitation, storm development, and weather movement patterns. Real-time weather information allows aircraft and vessels to avoid dangerous conditions or plan routes around developing storms. The radar coverage extends well beyond Bermuda's immediate vicinity, providing advance warning of approaching weather systems. Integration with international weather networks provides comprehensive coverage of Atlantic weather patterns affecting the Triangle region. Modern weather radar can detect wind shear, turbulence, and other atmospheric hazards that pose risks to aviation operations. The system provides both current conditions and short-term forecasts, enabling better planning for Triangle operations. This weather monitoring capability eliminates the element of surprise that made historical storms so dangerous to Triangle travelers. 75. Hurricane Highway. The majority of Atlantic tropical storms and hurricanes pass through or near the Bermuda Triangle region during their life cycle, making severe weather the most significant genuine hazard in the area. The Triangle's position places it directly in the path of storms moving northward from tropical formation areas in the Atlantic and Caribbean. Hurricane season, lasting from June through November, brings multiple severe weather threats to the Triangle region annually. These storms can develop rapidly from minor disturbances to major hurricanes within 24 to 48 hours, creating dangerous conditions with little warning. Hurricane-force winds, extreme waves, and torrential rainfall create conditions that challenge even modern vessels and aircraft. The frequency of severe weather in the Triangle provides a rational explanation for many historical incidents that were previously considered mysterious. Modern weather forecasting and satellite monitoring provide advance warning of these storms, but they remain formidable natural hazards. The concentration of severe weather in the Triangle region demonstrates that natural forces, rather than supernatural phenomena, pose the primary dangers in the area. 76. Annual storm predictions. The National Oceanic and Atmospheric Administration typically forecasts 14 to 19 named storms annually in the Atlantic Basin, with the majority affecting or passing through the Bermuda Triangle region during their development or movement patterns. This annual storm frequency makes the Triangle one of the most weather-active regions in the North Atlantic during hurricane season. The 14 to 19 storm average represents long-term climate patterns based on decades of historical weather data. Named storms include both tropical storms and hurricanes, with varying levels of intensity and potential impact. The predictable annual pattern of storm activity allows for seasonal planning of triangle operations and safety preparations. NOAA's forecasting accuracy has improved significantly with satellite technology and computer modeling, providing better advanced planning capability. The high frequency of named storms demonstrates that severe weather is a routine rather than exceptional feature of triangle conditions. Understanding this annual storm pattern helps explain why the triangle has historically been the site of weather-related maritime and aviation incidents. 77. Hurricane development statistics. Of the 14 to 19 named storms that typically develop each Atlantic hurricane season, 5 to 9 typically intensify into hurricanes, with 2 to 5 reaching Category 3 strength or higher, creating extremely dangerous conditions in triangle waters. This statistical pattern demonstrates that major hurricanes regularly affect the triangle region, posing serious threats to all forms of transportation. Category 3 hurricanes produce winds of 111 to 129 miles per hour, creating waves over 40 feet high and extremely dangerous flying conditions. The 2 to 5 major hurricanes per season represent a significant and recurring threat that requires careful planning and preparation. Hurricane intensity can change rapidly, with storms strengthening or weakening significantly within 24-hour periods. The regular occurrence of major hurricanes in the Triangle region provides natural explanation for many historical incidents attributed to supernatural causes. Modern hurricane tracking and forecasting provide advance warning that was not available during the era of most triangle mysteries. These statistics demonstrate that severe weather represents the most significant ongoing threat to triangle operations. 78. White squalls strike without warning. The Bermuda Triangle region experiences frequent white squalls, intense, localized storms that can develop suddenly in otherwise calm conditions, creating dangerous situations for vessels and aircraft with little or no advance warning. White squalls are characterized by their rapid development and brief duration, often lasting only 15 to 30 minutes, but producing severe winds and precipitation. These storms can generate winds exceeding 50 miles per hour from calm conditions within minutes, creating hazardous seas and dangerous flying conditions. The term white squall refers to the white-capped waves generated by sudden intense winds in previously calm waters. White squalls are particularly dangerous because they develop too quickly for traditional weather forecasting to provide adequate warning. These sudden storms may explain some historical triangle incidents where vessels or aircraft encountered unexpected severe weather. Modern Doppler radar can sometimes detect white squall development, but their rapid formation still makes them challenging to predict. The frequency of white squalls in the Triangle region adds another layer of natural weather hazard to an already challenging environment. 79. Wasserspouts-Triatennavigation. Waterspouts pose significant risks to vessels and aircraft operating in the Triangle region, creating tornado-like conditions over water that can damage or destroy craft caught in their path. Waterspouts are essentially tornadoes that form over water, with rotating winds that can exceed 100 miles per hour in severe cases. The Triangle's warm water temperatures and atmospheric conditions make it particularly susceptible to waterspout formation. These phenomena can develop rapidly and move unpredictably, making them difficult to avoid once they form. Waterspouts can lift small aircraft or severely damage vessels that encounter them directly. The visual similarity between waterspouts and strange atmospheric phenomena may explain some historical triangle mystery reports. Modern weather radar can detect waterspout formation, providing some advance warning for triangle operations. Multiple waterspouts can form simultaneously, creating widespread hazardous conditions across large areas of triangle waters. 80. The Pride of Baltimore lesson. The 1986 sinking of the Pride of Baltimore demonstrated how rapidly weather conditions can change in triangle waters, with winds suddenly shifting from 20 miles per hour to 60 to 90 miles per hour, overwhelming the sailing vessel and claiming 4 lives. This tragic incident occurred during a sudden weather change that gave the crew insufficient time to reduce sail and prepare for severe conditions. The Pride of Baltimore was a replica 19th-century schooner that was particularly vulnerable to sudden wind shifts due to its traditional rigging. Wind speeds increased by 300 to 400% within minutes, creating forces that exceeded the vessel's ability to handle under its current sail configuration. The incident demonstrates how even experienced crews with seaworthy vessels can be overwhelmed by triangle weather conditions. 4 crew members died in the sinking, while 8 others were rescued after spending time in life rafts. The Pride of Baltimore incident illustrates how sudden weather changes can create conditions that seem mysterious to those unfamiliar with the triangle's meteorological characteristics. This well-documented incident provides insight into how rapid weather changes may have contributed to historical triangle mysteries. 81. Extreme temperature variations. Sea surface temperatures in the Bermuda Triangle range from 68 degrees Fahrenheit in winter to 82 degrees Fahrenheit in summer, creating significant thermal gradients that affect underwater visibility, marine life distribution, and atmospheric conditions. The 14-degree temperature range creates distinct seasonal conditions that affect navigation, fishing, and recreational boating activities. Winter temperatures of 68 degrees Fahrenheit are still warm enough to support tropical marine life, making the triangle unique among northern Atlantic regions. Summer temperatures reaching 82 degrees Fahrenheit create ideal conditions for hurricane development and severe weather formation. The temperature variation affects water density, creating thermal layers that can impact sonar performance and underwater operations. Rapid temperature changes can create fog and visibility problems as air masses with different temperatures interact. The warm water maintains coral reef ecosystems that create both natural beauty and navigation hazards. These temperature extremes contribute to the triangle's complex oceanographic and atmospheric conditions. 82. Incredible marine biodiversity. The waters of the Bermuda Triangle support over 600 documented fish species within the broader coral reef ecosystem, creating one of the most biologically diverse marine environments in the North Atlantic. This extraordinary biodiversity results from the unique combination of tropical and temperate conditions created by the Gulf Stream's influence. The 600 fish species include tropical varieties at the northern limit of their range and temperate species extending southward. The coral reef ecosystem provides habitat complexity that supports this remarkable species diversity. Many of these species are commercially important, supporting fishing industries that operate throughout the Triangle region. The diverse marine life includes everything from small tropical fish to large pelagic species like marlin and tuna. This biological richness attracts researchers, recreational divers, and fishing enthusiasts from around the world. The healthy marine ecosystem demonstrates that triangle waters support normal biological processes without interference from alleged supernatural phenomena. 83. Floating seaweed meadows. Large quantities of floating sargassum seaweed characterize the Triangle region's unique marine habitat, creating distinctive conditions that have influenced navigation and marine life for centuries. Sargassum forms massive floating mats that can extend for miles, creating the appearance of solid land from a distance. These seaweed meadows provide habitat for numerous marine species, including fish, sea turtles, and countless invertebrates. The floating seaweed can interfere with vessel propellers, water intakes, and navigation equipment if encountered in large quantities. Sargassum accumulations vary seasonally and can shift location based on currents and weather patterns. Christopher Columbus wrote about these seaweed formations during his historic voyages, describing them as one of the most unusual features of Atlantic navigation. The seaweed meadows create unique ecosystem conditions found nowhere else in the North Atlantic. Large sargassum accumulations may have contributed to historical navigation difficulties and unusual sightings in the Triangle region. 84. Archaeological treasure trove. The Triangle region contains numerous significant archaeological sites, including the Sea Venture from 1609 and hundreds of other shipwrecks that provide insights into centuries of maritime history. The Sea Venture was the flagship of the Virginia Company fleet and played a crucial role in the early colonization of America. The shipwreck sites range from Spanish colonial vessels to modern cargo ships, representing over 400 years of maritime activity. These archaeological sites are preserved by the clear, warm water conditions that characterize much of the Triangle region. Marine archaeologists consider the Triangle one of the richest underwater archaeological areas in the Western Hemisphere. The shipwrecks provide evidence of the natural hazards, reefs, storms, and navigation challenges that have always made Triangle waters dangerous. Many wrecks contain artifacts that help historians understand the development of Atlantic trade and navigation. The concentration of archaeological sites demonstrates the Triangle's importance as a maritime corridor throughout recorded history. 85. Advanced sonar reveals hidden terrain. Advanced sonar systems operating in Triangle waters have revealed complex underwater topography, including submarine landslide escarpments, extensive cave systems, and sediment channels with intricate branching patterns. This sophisticated mapping technology provides unprecedented detail about the Triangle's seafloor structure and geological features. Submarine landslide escarpments indicate past geological instability that may have created underwater avalanches and tsunami-like waves. The extensive cave systems create three-dimensional underwater terrain that affects currents, marine life distribution, and navigation hazards. Sediment channels show evidence of powerful underwater currents that transport material across the seafloor. The branching patterns of these channels resemble river systems, indicating complex underwater hydrology. These geological features help explain the Triangle's complex oceanographic conditions and potential navigation hazards. The detailed sonar mapping demonstrates how much about the Triangle's underwater landscape was unknown until recent technological advances. 86. Comprehensive seafloor mapping. Multi-beam bathymetry technology has successfully mapped over 180 kilometers of seafloor around the 100-meter depth contour in Triangle waters, revealing complex underwater topography previously unknown to science. This comprehensive mapping effort represents one of the most detailed seafloor surveys ever conducted in the Triangle region. The 100-meter contour represents the boundary between shallow reef areas and deeper oceanic waters. Multi-beam technology provides precise depth measurements and detailed three-dimensional images of seafloor features. The 180-kilometer mapping coverage includes critical areas around Bermuda, where most historical navigation hazards are concentrated. This detailed bathymetric data improves navigation safety by identifying previously unknown underwater obstacles and depth variations. The mapping project has revealed numerous features that don't appear on traditional nautical charts. The comprehensive seafloor data demonstrates how modern technology is solving mysteries about Triangle underwater terrain that existed for centuries. 87. Diverse ecosystems in northern waters. The coral reef systems in Triangle waters support some of the most diverse marine ecosystems in the North Atlantic, creating unique biological communities that thrive in the northernmost tropical conditions in the Atlantic Ocean. These ecosystems represent a biological anomaly, supporting tropical species far north of their normal range. The Gulf Stream's influence creates pockets of Caribbean-like conditions that allow tropical coral reefs to flourish. The ecosystem diversity includes hard corals, soft corals, tropical fish, sea turtles, and countless invertebrate species. These biological communities are particularly vulnerable to environmental changes and serve as indicators of ocean health. The unique ecosystem attracts marine biologists and researchers from around the world. The diverse marine life provides economic benefits through fishing, diving, and ecotourism activities. The healthy ecosystem demonstrates that Triangle waters support normal biological processes without interference from alleged supernatural phenomena. 88. Coral at the edge of survival. The Triangle's coral reefs include brain coral and staghorn coral thriving at the northern limit of their natural range, creating unique biological conditions supported by the Gulf Stream's warm water transport. These coral species typically live in tropical waters much farther south, making their presence in Triangle waters scientifically significant. Brain coral formations create massive underwater structures that have been growing for hundreds or thousands of years. Staghorn coral provides complex habitat structure that supports numerous fish species and marine invertebrates. The northern limit location makes these coral communities particularly valuable for studying climate change effects and species adaptation. The coral reefs create both natural beauty and significant navigation hazards for vessels operating in shallow water. These coral communities demonstrate the triangle's unique position at the intersection of tropical and temperate marine environments. The presence of thriving coral reefs indicates stable, healthy water conditions rather than the electromagnetic disturbances alleged in triangle mythology. 89. Modern mystery solved. The identification of the SS Cotopaxi wreck in 2020, originally thought lost in the triangle in 1925, demonstrates how improved underwater technology is systematically solving historical triangle mysteries. The Cotopaxi had been missing for 95 years when marine archaeologists positively identified the wreck using advanced sonar and diving technology. The ship was found in waters off the Florida coast, outside the traditional triangle boundaries, contradicting popular accounts of its disappearance. The wreck's condition and location provided clear evidence of the actual cause of the vessel's loss, eliminating supernatural explanations. Advanced underwater survey technology made the identification possible after decades of unsuccessful searches. The Cotopaxi discovery represents one of several triangle mysteries solved by modern archaeological techniques. The ship's identification demonstrates how incomplete information and limited search technology contributed to historical triangle mysteries. This recent discovery illustrates the ongoing process of solving triangle mysteries through scientific investigation rather than supernatural speculation. 90. Technology solves old mysteries. The Cotopaxi identification demonstrates how improved technology is systematically solving historical triangle mysteries that seemed inexplicable when they occurred, providing rational explanations for previously supernatural phenomena. Advanced sonar systems can now locate and identify shipwrecks that were impossible to find with earlier search technology. Remote operated vehicles, ROVs, allowed detailed investigation of deep-water wreck sites that were previously inaccessible. GPS technology enables precise documentation of wreck locations and conditions for future reference and study. Digital photography and 3D modeling create permanent records of wreck sites and their artifacts. DNA analysis can sometimes identify human remains found at wreck sites, providing closure for families of missing persons. Computer databases allow researchers to cross-reference wreck discoveries with historical records of missing vessels. The systematic application of modern technology to historical triangle mysteries is gradually eliminating supernatural explanations through factual evidence. 91. Centuries of maritime history. Over 300 documented shipwrecks spanning from the 17th century to modern times exist in triangle waters, creating an underwater museum that chronicles 4 centuries of Atlantic maritime activity. This extensive collection of shipwrecks represents one of the highest concentrations of maritime archaeological sites in the world. The 17th century wrecks include Spanish colonial vessels carrying treasure and trade goods between Europe and the Americas. 18th and 19th century wrecks document the development of Atlantic commerce and the evolution of ship design and construction. 20th century wrecks include modern cargo vessels, fishing boats, and recreational craft lost to various causes. Each wreck provides insights into the historical period when it was lost, including cargo, construction techniques, and navigation methods. The preservation of these wrecks in triangle waters allows detailed archaeological study of maritime history. The concentration of shipwrecks demonstrates that triangle waters have always posed natural hazards to navigation, long before the region became famous for supernatural mysteries. 92. Ongoing archaeological discoveries. Underwater archaeological discoveries continue providing insights into the Triangle region's extensive maritime history, with new wreck sites and artifacts regularly discovered by advancing underwater technology. Marine archaeologists estimate that hundreds of additional shipwrecks remain undiscovered in Triangle waters. New discoveries include both historical vessels from centuries past and more recent wrecks from the 20th century. Advanced side-scan sonar and magnetometer surveys continue to locate previously unknown wreck sites. Each new discovery adds to the understanding of Triangle maritime history and the natural hazards that claim these vessels. Archaeological evidence consistently points to natural causes, storms, reefs, navigation errors, rather than supernatural phenomena. The ongoing discovery process demonstrates that Triangle mysteries have rational explanations waiting to be uncovered by scientific investigation. These archaeological findings provide concrete evidence about Triangle maritime history that contradicts supernatural theories. 93. International Safety Standards. International Safety of Life at Sea, SALAS. Regulations mandate specific safety equipment for vessels operating in international waters, including Triangle areas, ensuring comprehensive safety preparations for all commercial maritime operations. SALAS represents the most important international treaty addressing maritime safety, with requirements that apply globally, including Triangle waters. The safety equipment mandated by SALAS includes emergency beacons, life rafts, survival suits, and communication systems. These regulations require regular inspection and maintenance of safety equipment to ensure operational readiness. SALAS standards apply to all commercial vessels over certain sizes, ensuring consistent safety preparations regardless of flag state. The international nature of these regulations means that vessels from all countries operating in Triangle waters must meet the same safety standards. Compliance with SALAS requirements has dramatically improved maritime safety since the regulations were implemented. The comprehensive safety standards mandated by SALAS make mysterious disappearances of properly equipped commercial vessels virtually impossible. 94. Global Maritime Distress System. The Global Maritime Distress and Safety System, GMDSS, ensures that ships operating anywhere on Earth, including Triangle waters, can communicate distress alerts and receive safety information regardless of their location. GMDSS represents a comprehensive approach to maritime communication that provides multiple redundant systems for emergency communication. The system includes satellite communication, digital selective calling, and emergency position indicating beacons. GMDSS coverage is truly global, extending to the most remote ocean areas where traditional radio communication would be impossible. The system automatically alerts search and rescue authorities when emergency beacons are activated, eliminating delays in emergency response. Ships equipped with GMDSS equipment can communicate with rescue authorities even when their primary communication systems fail. The system provides both distress communication and routine safety information, including weather forecasts and navigation warnings. GMDSS implementation has essentially eliminated the communication failures that may have contributed to historical Triangle mysteries. 95. Comprehensive Maritime Monitoring. Modern vessel traffic management systems integrate radar, automatic identification systems, AIS, and closed-circuit television to provide comprehensive monitoring of ship movements in busy waterways throughout the Triangle region. These integrated systems provide real-time tracking of vessel positions, courses, and speeds with unprecedented accuracy. AIS technology requires ships to broadcast their identity, position, and navigation status continuously. Radar systems provide backup tracking capability and can detect vessels not equipped with AIS transponders. CCTV systems allow visual confirmation of vessel activities in critical areas like harbor approaches and reef passages. The integration of multiple monitoring technologies eliminates gaps in surveillance coverage that existed with older systems. Comprehensive monitoring makes it virtually impossible for properly equipped vessels to disappear without immediate detection. This technological integration demonstrates how modern maritime safety systems have eliminated the conditions that contributed to historical triangle mysteries. 96. Real-time ship tracking. Real-time vessel tracking systems provide global visibility of ship movements with automated position reporting and collision avoidance capabilities that make unexplained disappearances virtually impossible for commercial vessels. These tracking systems use satellite communication to provide continuous monitoring of vessel positions worldwide. Automated position reporting eliminates the need for manual radio communications that could fail during emergency situations. The global coverage includes remote ocean areas where traditional communication methods would be unreliable. Collision avoidance systems use tracking data to predict potential encounters and warn vessels of dangerous situations. Emergency response can be initiated immediately when tracking systems detect unusual vessel behavior or emergency signals. The continuous nature of modern tracking means that any interruption in normal reporting immediately triggers investigation. Real-time tracking represents a quantum leap in maritime safety compared to the periodic radio communications used during the era of triangle mysteries. 97. Advanced air traffic control. The Bermuda Terminal Control Area provides comprehensive radar coverage within a 180 nautical mile radius extending up to 50,000 feet altitude, ensuring complete monitoring of all aircraft movements in triangle airspace. This radar coverage encompasses virtually all of the traditional triangle area, providing continuous monitoring of aircraft positions and communications. The 180-mile radius extends far beyond Bermuda itself, covering major portions of triangle airspace used by commercial and general aviation. Coverage up to 50,000 feet ensures monitoring of all aircraft operating at normal cruising altitudes. The radar system provides both primary radar returns and secondary surveillance data from aircraft transponders. Air traffic controllers maintain continuous communication with all aircraft operating within the coverage area. Emergency procedures are immediately implemented when aircraft fail to respond to radio calls or deviate from planned flight paths. This comprehensive air traffic control coverage makes unexplained aircraft disappearances virtually impossible in triangle airspace. 98. Automated aircraft identification. Secondary surveillance radar systems use aircraft transponders to provide automatic identity, altitude, and position data, eliminating the communication problems that may have contributed to historical aviation incidents in triangle airspace. These systems automatically identify every aircraft in triangle airspace without requiring radio communication. Transponder technology provides precise altitude information that helps controllers maintain safe separation between aircraft. The automatic nature of transponder identification eliminates the possibility of miscommunication about aircraft identity or position. Secondary surveillance radar operates independently of primary radar, providing redundant aircraft tracking capability. The system can detect transponder-equipped aircraft at much greater ranges than primary radar systems. Emergency transponder codes immediately alert controllers to aircraft in distress or facing hijacking attempts. This automated identification technology provides aircraft tracking capability that far exceeds what was available during historical triangle aviation incidents. 99. The end of mystery disappearances. The pattern of mysterious disappearances in the Bermuda Triangle virtually ended with the advent of satellite-based navigation and communication systems, demonstrating that technological advancement rather than supernatural intervention explains the region's changing safety profile. This correlation between technological improvement and the cessation of mysterious disappearances provides strong evidence for rational rather than supernatural explanations. Satellite-based systems provide capabilities that were impossible during the era when most triangle mysteries occurred. GPS navigation eliminates the compass and dead reckoning errors that may have contributed to historical incidents. Satellite communication ensures that distress calls can be transmitted and received even from the most remote ocean locations. Emergency beacons provide automatic distress signaling that operates independently of crew action. The timing of this change corresponds precisely with the implementation of modern navigation and communication technology. This technological explanation for the end of Triangle Mysteries provides compelling evidence against supernatural theories. 100. A living, working ocean. The Triangle region continues serving as a major shipping lane, military training area, and popular tourist destination, demonstrating that it functions as a normal, well-monitored ocean corridor rather than a mysterious danger zone. Thousands of commercial vessels transit Triangle waters annually without incident, carrying cargo worth billions of dollars. Military training exercises conducted regularly in Triangle waters proceed normally without unusual equipment failures or mysterious phenomena. Cruise ships carrying thousands of passengers operate scheduled routes through Triangle waters with excellent safety records. Recreational boating and fishing activities continue year-round, with normal accident rates comparable to other popular boating areas. Aviation routes through Triangle airspace carry millions of passengers annually with safety records that match global aviation standards. Scientific research vessels operate regularly in Triangle waters, conducting marine biology, oceanography, and geological studies. The region's continued use for normal maritime and aviation activities demonstrates confidence in its safety based on scientific understanding rather than supernatural concerns. 101. Technology conquers uncertainty. Comprehensive monitoring, instant communication, and precise navigation systems have replaced the isolation and confusion that characterized earlier maritime travel, transforming the Triangle from a place of uncertainty into a well-understood marine environment. Modern mariners and aviators have access to real-time weather information, precise navigation data, and instant communication capability. The isolation that made historical Triangle incidents so mysterious has been eliminated by satellite communication and global positioning systems. Navigation uncertainties that may have contributed to historical disappearances are no longer possible with GPS technology. Emergency response capabilities have improved dramatically, with rescue operations beginning within minutes rather than hours or days. The comprehensive nature of modern technology provides multiple redundant systems that prevent single-point failures. Understanding of Triangle oceanography, meteorology, and geology has advanced significantly through scientific research. This technological transformation demonstrates how human ingenuity and scientific advancement have conquered the natural challenges that once made Triangle waters seem mysterious. 102. Demonstrating human progress. The Triangle's transformation from a mysterious danger zone to a routine ocean corridor demonstrates humanity's technological conquest of natural navigation uncertainties and the power of scientific understanding to replace fear with knowledge. This transformation represents one of the clearest examples of how technology can solve problems that once seemed supernatural or inexplicable. The progression from mystery to understanding illustrates the scientific method's effectiveness in explaining natural phenomena. Technological solutions have addressed each of the problems that may have contributed to historical Triangle incidents. The change from fear-based folklore to science-based understanding represents significant progress in human knowledge. Modern safety systems demonstrate how engineering and technology can overcome natural hazards. The Triangle story shows how systematic investigation can replace supernatural speculation with factual understanding. This progress represents the broader human achievement of using science and technology to understand and control natural forces. 103. The triumph of science. Modern safety technology has eliminated the conditions that may have contributed to historical Triangle disappearances, representing a complete technological solution to what was once considered an unsolvable mystery. Each technological advancement has addressed specific problems that may have caused historical Triangle incidents. GPS navigation eliminated the compass errors and dead-reckoning mistakes that could lead vessels astray. Satellite communication eliminated the isolation that prevented distress calls from reaching rescue authorities. Weather monitoring eliminated the surprise storms that could overwhelm unprepared travelers. Emergency beacons eliminated the possibility of vessels disappearing without trace. Advanced sonar and mapping technology eliminated navigation hazards by precisely charting underwater obstacles. The comprehensive nature of these technological solutions demonstrates how systematic application of science and engineering can solve even the most puzzling mysteries.